plural, not do acid, right? Naming acids. Well, there's different ways to define acids. Acids are molecular compounds that form ions when dissolved in water. So we do not name acids as ionic compounds, but they form ions. And so that can get a little confusing at times. Usually when we see an acid, hydrogen will be the first element in the formula, followed by one or more nonmetals. So what we'll learn for this class is if the formula starts with H, it's an acid, and we're going to name it as an acid. We can group the acids into two categories, binary acids and oxyacids. Oxyacids have oxygen, and the binary acids do not. There's a flowchart, very, very small flowchart. So the binary acids are going to follow this pattern. They're going to use a prefix hydro and take the base name of that nonmetal and change the ending to ic, and then we're going to toss the word acid on the end. All acid names have acid as the second word in the name, so that makes them really easy to identify. So if we're naming HCl, we see the letter H being first, and we're going to name this as an acid. Technically, we only name it as an acid if it's dissolved in water, but we're not going to worry about that. So HCl, we find the non-hydrogen part is chlorine. So chlorine becomes chloric acid, and we put the prefix hydro on the front, hydrochloric acid. HBr, hydrobromic acid. HCl in its pure state is actually a gas at room temperature, and so if we see it with a G, that refers to hydrogen chloride, which is a molecular compound. And I just want to put that out there because if you take 1A after this, they'll get a little more hung up on that. But we're just going to learn the naming for acids. So H2S. We see the H, we say this is an acid. And we look at the rest of it. There's just one element, sulfur. This is not an oxyacid. So I'm going to use the prefix hydro. And the base name for sulfur, sulfuric acid, hydrosulfuric acid. Any questions? So what's HF aqueous? Hydrofluoric acid. And there's no flour here either. Hydrofluoric acid. It's not flour right in there, fluor. H2SE. Hydroselenic. Se is selenium, and so we take selenium and we make it selenic acid. The oxyacids have a bit of a different pattern. The names of these oxyacids are based on the names of the oxyanions that are in them. If we look at HNO3, the first element is hydrogen. That tells us it's an acid. Cover up the hydrogen and look at what's left, NO3. Does that look even vaguely familiar? That's nitrate, isn't it? So this has oxygen and another nonmetal. It's not just HN, it's HNO3. And so the name is based on the name of nitrate. H2SO3, cover up the H's. We've got SO3, 2-, that's the sulfite ion. There's H2SO4, that has the sulfate ion. The number of hydrogen ions is going to depend on the charge. This one has a -1 charge, and it has 1 hydrogen. Sulfate has a -2 charge, it's got 2 hydrogens. What group of the periodic table is hydrogen in? It's group 1, right? What charge do the metals in group 1 have? +1. Hydrogen often has a +1 charge also. He's over there on the left side of the periodic table thinking he's a metal, but actually he's just a little baby. He's not a man. But he's over there acting like one. You know, like when the 2-year-old puts on daddy's shoes and clomps around the house. That's hydrogen. Hydrogen +1. So all we have to do, is look at the charge, and because hydrogen's +1, it's always the same as the charge. So those oxyacids, they have an oxyanion in them. Oxyanions can have one of 2 endings, -ite or -ate. There's chlorite and hypochlorite. Both of those are ites. There's chlorate and perchlorate. Both of those end in -ate. So if it ends in -ite, we change that -ite to -us and put the acid on the end. If it's -ate, we change it to -ic and put acid on the end. And that's hard to remember. So, I have a silly sentence for you. I have lots of silly sentences. Rick ate him before he could bite us. Rick ate him before he could bite us. It's a little bit of a stretch with the spelling there, but you get the idea. So here's ite and us. Those 2 go together. Ick and ate go together. So looking in this table, which I can't see because it's too small, HNO2 has NO2 in it. NO2 is nitrite. We change the ite to us and add the word acid. This is nitrous acid. There's no hydro in front. Hydro in front means it's a binary acid, no oxygen. Let's look at this one. There's a mistake in table 5.7. This is from the 4th edition. I'm hoping they fixed it in the 5th edition, but I'm not going to hold my breath. It's HC2H3O2. And this H is not lumped in with the other H's because this is what makes it an acid. So we cover up the H and we look at what's left. C2H3O2. That's in that table, and its name is acetate. Well, acetate. Change ate to ick. This is acetic acid. It has a -1 charge, and so it has 1 hydrogen on it, not 2, as it said in the original table. That's naming oxyacids. And this first one is dumb. I need to change it because, well, actually, let's just change it. Let's make this H3PO4. We talked about HNO2 twice already. This is an acid because it starts with H. Cover up the H's and what's left? PO4, 3-, and the name of that, what's a good guess? Phos something, right? That's phosphate. So we're going to change the 8 to ick. This is phosphoric acid. Now, where did the OR come from? Phosphorus and sulfur sometimes bring part of their original name back. Sulfate becomes sulfuric, not sulfic. And phosphate becomes phosphoric, not phosphic acid. It sounds better. That's the only explanation I can give you. Sorry. It's like the English language, you know. The way we conjugate verbs is horrendous. It's absolutely horrendous. Okay, here's another one, HClO4. H at the beginning tells us this is an acid. Cover up the H and look at what's left. ClO4 minus. I can figure out its charge from this formula because there's one hydrogen. It must be -1. Here, H3PO4, there were 3 hydrogens. That told me the charge was -3. But I can also find that out by looking in the table or in my memory bank where I've stored this information. ClO4 has what name? I'll give you a hint. ClO3 minus is chlorate. So what's the one that has an extra? Perchlorate. So perchlorate. Change 8 to perchlorus or perchloric? Ick. Rick ate him. Ate an ick. Perchloric acid. And there is a table that sort of summarizes all of this nomenclature. Look at all the pretty colors. Here's a flow chart showing you how you might go through that. Here's a table showing you how you might use the flow chart to figure out a name. That may or may not be helpful. And we'll save this part for later.